Hello all, I am Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. In today's lecture series, we are going to discuss about virtual reality physical modeling part 3. Okay. See here, in haptics rendering pipeline, already we have discussed about traversal and force. In force, we have discussed about force calculation, force mapping and force smoothing. And the last one is haptic. Okay, why do we need this haptic? What is haptic mesh? Okay, see here, a haptic mesh. A single HIP is not sufficient to capture the geometry of fingertip object contact. See the sample figure. The curvature of the fingertip and the object deformation need to be realistically modeled, because a single haptic point, it doesn't give any real world object experience. So we need a haptic mesh which will provide a better experience than haptic interface point. See here the screen sequence for squeezing an elastic virtual ball. See here the first scene 1, scene 2, scene 3 and 4. Here a single haptic interface point is not enough, so we move on to haptic mesh. See the haptic mesh. First mesh point I, and see the second one, penetration distance for mesh point I. See the whole curvature is covered. Here to calculate this haptic mesh force, F haptic mesh I, it is equal to K object and it is multiplied with D mesh I and multiplied with N bar surface. For each haptic interface point of the mesh, we have to calculate this. Here, where D mesh I are the interpenetrating distances at the mesh points, and N bar surface is the weighted surface normal of the contact polygon. Here, see the picture. Here the penetration distance for mesh point I and haptic interface point I are denoted here. See here where D mesh I are the interpenetrating distances at mesh points, and N bar surface is weighted surface normal of the contact polygon. Okay. Next one is, in haptics rendering pipeline, we have discussed force calculation, force smoothing and force mapping, and for this haptic mesh we have to calculate the force mapping. So here for force mapping, the force displayed by the Rugger's master interface, here F displayed, it is equal to summation F haptic mesh multiplied with cos theta, where theta it is the angle between the mesh force resultant and the piston. Here see here the haptic mesh and force displayed and force global. Here we have theta angle between mesh force resultant and the piston. See here this haptic mesh, the full formation of haptic mesh, it provides a real world feeling of that particular object. Here we have chosen the elastic ball. So here this force mapping with this haptic mesh, which provides a real elastic ball pressing at this moment in a virtual reality world. Okay, see here in this haptic texturing, which is under tactile, and here see this tactile mouse, and also we have to analyze this tactile patterns produced by the Logitech mouse. Okay, see here force with respect to time, at second interval and the third one. See the differences, the first one, second one and the third one. See here, this is a tactile pattern produced by the Logitech mouse. Okay, see here the explanation for that tactile. Here see here, first here we have bump magnitude at left side, and also we have bump magnitude at right side, and also we have bump size at the left as well as right. Also we have bump spacing at the left as well as right. and in between and center we have force, and also we have bump spacing downward, bump size downward. Same for upward, we have bump size upward, bump spacing upward. Also we have bump magnitude at the downward and bump magnitude at the upward. See here, with the help of this bump magnitudes at both sides as well as upward and downward, which provides a full haptic mouse texture simulation at the virtual reality environment. We have to analyze each and every side of the real world object to give a better experience in the virtual world. Okay, see here, surface haptic texture produced by the phantom interface. Here we have contact forces in the object surface, and here the force Fx, it is equal to A multiplied with del H by del power x. See here, del x, the distance between the 2 points. Here the point is xi minus 1 and xi plus 1 at the right side, minus 1 at the left side. And also we have to calculate the height at the upward as well as the downward sides to produce the exact experience in the VR world. Okay, see the haptic interface point. Here we consider the object polygon which has the world coordinates x, y and z. Here f texture which is equal to a sin mx multiplied with sin ny, where a, m and are constants. A gives magnitude of vibrations and m and n modulate the frequency of vibrations in the x and y directions. So we have to calculate both magnitude as well as frequency for better feedback. Thank you.